anatomical target states. When we combine these ideas, we see a topological landscape. Target states act as gravity wells, or attractors, that pull the system toward a specific configuration. If a system drifts away from its target state, it generates a measurable prediction error signal. In the manifold, this mathematical error is structural stress, the cognitive glue for the collective. The system shares and distributes this stress signal. This shared tension pulls disparate agents back into alignment, forcing them to self-correct toward the attractor. Biological coordination is the process of sharing and minimizing mathematical stress across a network. We have an informational ledger and a landscape of attractors, but we must identify the physical substrate that supports these shapes. Theoretical physics points toward positive geometry, objects like the amplitudrum. These static mathematical structures encode the constraints that govern physical interactions. This creates a constraint-attractor duality. The flexible landscape of biological and cognitive attractors is an emergent projection of this rigid geometric foundation. This model is substrate independent, mapping directly onto artificial intelligence. Both systems navigate high-dimensional landscapes. We steer an LLM through its latent space using vectors, just as vector-based logic drives biological subagents to attractors. The control loop geometry remains identical. Reinforcement learning from human feedback is an application of this. We inject functional stress to alter the AI's internal geometry, shifting its target states to align with ours. This explains why multi-agent misalignment in an AI and cognitive trauma in a biological brain share similar mechanics. Both are failures of representational coherence, instances where the internal model cannot reconcile conflicting data within its geometry. The manifold is now complete. It begins with discrete ledger commits, scales into sub-agent control loops, and is guided by stress-minimizing attractors, all anchored in positive geometry. This architecture scales from the individual mind to the ledger of the universe itself. Because every physical interaction is an informational event, the principles of control and alignment we see in cognition are present at every level of reality. By using computational phenomenology, we can read the Jacobian of experience, the mathematical output of how these systems model their own internal states. This provides a shared toolkit for diverse challenges: regenerating tissue, aligning superintelligent AI, and mapping the structure of quantum gravity. We live in a world defined by multi-agent control loops. Reality is the byproduct of pure information processing, operating on a single unified manifold.